Hi, pre-calc students. This video will just have a little bit more practice solving some 3x3 systems. So before we get into just a little bit more practice, I figured I'd show you the answers from the textbook homework from last night. Section 7.3, I asked you to do 43 through 50. So not very exciting solutions here because it's not the work done out, but these are at least the answers. If you have questions about any of this stuff, I'm hoping that maybe you'll potentially ask me about that tomorrow during our Google Meet session, but otherwise, go ahead and check these out. Pause if you need to. 50 had a no solution. I'm guessing those lines had to be parallel in that case. That's the time where we get no solution. Okay, so I actually, to get started today, have a sample situation that would be modeling a system in the real world. And I adapted it a little bit. I took some creative liberties to maybe make it seem realistic to what we're going through in this time away from school here. So here's the following situation. It says, during the Great Quarantine of 2020, 3 students did some online shopping at one size fits all. Our 3 students are Sean, Addie, and Alexis. And Sean got 1 pair of socks, 1 shirt, 1 pair of pants for $75. Sean's a simple guy, just needs 1 of each. Okay, I mean, nobody's seeing Sean here, so he can probably get away with wearing those each day. Addie needed a little bit more variety in her wardrobe here. She got 2 pairs of socks, 2 shirts, 4 pairs of pants for a total of $250. And then finally, Alexis, she's got cold feet going on. She needed 3 pairs of socks, 1 shirt, and 2 pairs of pants for a total of $135. So the natural question becomes, well, how much is each item individually? Okay. So the way we're going to solve this is we have 3 unknown variables: the cost of socks, the cost of shirts, the cost of pants. And luckily we have 3 very willing online shopping participants. So you see where I'm headed, right? We're going to do a system of 3 equations with 3 unknowns just to kind of make my life a little bit easier. I'm going to quickly define off to the side that let's let X, Y, and Z represent the socks, shirts, and pants options here. I was going to actually use the variables S and then P for pants, but unfortunately we got socks and shirts here, so that would be a little confusing if I tried to use just S and P, I guess. So I think if we just stick with X, Y, Z, we'll be good to go. But in the end, what we're going to have is that first equation would say X plus Y plus Z equals 75. So the first row of the matrix would say 1, 1, 1, 75. And similarly, if we had 2x plus 2y plus 4z equals 250, that gives us 2, 2, 4, 250. And the last for Alexis is 3, 1, 2, 135. So just as kind of a quick reminder of what we're looking to do here, we want to get this into what's called row echelon form, which means that if I draw my staircase in from yesterday's lesson, we need 1s on the steps. We need 0s underneath the steps. If there's already a 1 on the top step, next goal is to make some 0s underneath it. I'm going to try and go a little crazy here and actually make both of these 0s by writing the work off to the side as far as what those row operations should be. You do not have to follow me in this exact manner. You can separate it into 2 distinct steps, but I would allow you to do this, where if I want to make that 2 a 0, it's -2 row 1 plus row 2. That's going to be the new row 2. And if I wanted to make that 3 a 0, it's -3 times row 1 plus row 3. That's going to be the new row 3. So that's just one additional layer that if you'd like to maybe not have to write that matrix so many times, you can make both of those 0s at once. I'll allow you to do that. Row 1 in this process will never change, 1, 1, 1, 75. And then row 2, if I carefully do this, -2 times 1 is -2, plus 2 is 0. Good, that's what I want to have happen. -2 times 1 is -2, plus the 2 below it is 0 again. -2 plus 4 is 2. And this is going to be -150 plus 250 for a total of 100. And then from there, we would get this operation to get row 3, right? So -3 times 1 is -3, plus 3 is 0. -3 plus that 1 is -2. -3 plus 2 is going to be -1. And finally, that last row there, that's going to be -225 plus 135, I think is -90, guys. But you know what? Just so that I don't make a mistake with this, and just to model this for you as an okay technique, do it on the calc. -3 times 75, add it to 135, and just as I told you, look at that, -90. Good. All right, so we get -90 in the spot. So then I'm going to draw that staircase back in here. And the next thing I want to do is I want to make that oh no, I want to make that a 1. But the issue is when we make 1s, we're supposed to be able to multiply a row by the reciprocal of what's there. So I can't really make that into a 1 because there's nothing I can multiply 0 by to magically turn it into a 1. Luckily, we are also allowed to switch rows. So don't forget that you can actually bring that -2 up to this step by switching the rows. Okay. And then from there, we'll try and make that -2 into a 1 in just a moment here. Make sure you take everything from that bottom row and move it up, and everything from the middle row and move it down there. So now I can go ahead and think about, okay, let's make this -2 into a positive 1. So that's going to require me to take row 2 and multiply it by -1/2. That will become the new row 2. So we get 1, 1, 1, 75. 0, now this is a positive 1. -1/2 times -1 is +1/2. And -1/2 times -90 is positive 45. Bottom row, 0, 0, 2, 100. And the nice thing about switching those rows, by the way, is notice how that made a 0 underneath this step here. That would have been my next step. Had it not been a 0, I would have had to have changed that. But last thing I got to do is maybe make that 2 into a 1. So take row 3, multiply it by 1/2. That becomes the new row 3. 1, 1, 1, 75. 0, 1, 1/2, 45. And the last row is now 0, 0, 1, and 50. So it turns out that the value of z, if I use that bottom row, z would be 50. All right, now we're just going to back substitute like we've seen before. So we're going to get, in the second row, y plus 1/2 of z is 45. So remembering that z is 50, 1/2 of 50 is 25. So if I subtract that to the other side, we get that y is 20. And if I go all the way up to that top equation, we would have x plus y plus z equals 75. Y and z added together is a total of 70, right? 50 and 20. So then, therefore, x is 5. So when all is said and done, oh, sorry, guys, you actually could not see that while I was doing it, but hopefully it was all making sense. Okay. So when all is said and done, we actually get the value of x to be 5. Remember, x was our socks, so that means socks cost $5. Y was the shirts, so shirts cost $20. And I don't know about you guys, but a very expensive pair of pants here for $50. But if you only have to buy one to get through the quarantine, maybe it's not such a bad deal. And hey, one size fits all, of course. So, all right. So we've got one quick application, but really at the end of the day, what were we doing here? We're trying to figure out how do we solve a 3x3 system using these row operations. That is, I think, all I wanted to model for you today. What I'm going to write down quick for you now is the suggested problems in the textbook, aka your homework. So let me see if I can find that sheet here. I'd like you to, and this is on the website, but take a look at 7.1, numbers 33 through 36. These are all going to be 3x3 systems. And if you wanted to right now, you could actually stop the video and you can go try those. But because I'm actually such a nice, generous guy, I'm actually going to do just 33 with you to get the party started. And then hopefully you'll be able to take that just as one more example of a 3x3 system and go ahead and try the other 4. Okay. So we've got 1, 1, -1, and negative or +6 for the top row. Super important that you copy the matrix over correctly. Otherwise, there is no way for you to get a correct solution in the end. And then here's my bottom row here. So hit pause quick, go ahead and copy that matrix down yourself. And then let's get started. So here's my staircase, top step. I want that to be a 1, already done. So like I showed you a second ago, I'm okay if you turn these both into zeros, writing the work off to the side in that first step of the matrix. So I'm going to do -2R1 plus R2. That's the new row 2. And to make this a 0, you're just going to negate R1 and add it to R3. That's the new row 3. All right. So row 1's not changing. Again, if you're like, no, Mr. All, I want to try it on my own, go for it, right? You guys can go ahead and stop the video now. Try this on your own. Okay, so this would be a 0 in this spot if I did that correctly. -2 times 1 is -2, plus -1 is -3. This is going to be +2 plus 1 is 3. And then -6 and -9 is -15 in this spot right here. Except I didn't multiply it by -2. I was just looking at something. I was like, that doesn't make sense. Let me try that again. -12 plus -9 is actually -2. How am I going to fix that to -21? That's a 2. That's not so bad. Yikes. Sorry about that. -21. All right, bottom row, we know this is a 0 for sure. Negate this and add it to the row below it. That becomes -3. This is going to become a +1 plus 3, which is 4. -6 and 1 is a total of -5. Okay. So it looks like we're in a good place now. Go ahead and draw that staircase back in. And then on the second step, we don't want -3. We want +1. So take row 2, multiply it by the reciprocal, -1/3. Here's the new system. Top row is the same. Second row is 0, 1, -1. And this is going to become a +7. Okay. Row 3 is the same. And draw the staircase back in. Next part of the process. We didn't have to do this before, but we have to make that a 0 in this one. Remember, when you're making this specifically as 0, you have to go to row 2 and multiply it by something. Don't go up to row 1. Even though you're like, hey, Mr. All, can I just multiply that by 3 and add it to this row? Yes, but it's going to change that 0 that we worked so hard to make earlier. So don't do that. Go to row 2, multiply it by 3, and then add it to row 3, and you'll find that that 0 will not change. So we've got 1, 1, -1, 6. We've got 0, 1, -1, 7. Bottom row, 0, 0 now. -3, and then +4 is a 1. And then 21 minus 5 should be 16. Look how nice that last step was, guys, because on the last step, I'd really want a 1. And we got kind of lucky that in this operation, it already turned it into a 1. So right now we know z is 16. All right, go back and back substitute now. So if z is 16, go to the second row. And it would say y minus z equals 7. So if y minus 16 equals 7, that means that y equals 23 if I add the 16 over. And finally, if you go back up to the very top row here, all right, we've got x plus y minus z is equal to 6. So x plus 23 minus 16 equals 6. So if I do 23 minus 16, that should be 7. If you subtract 7 over, you get x equals -1. So the solution to the system should be -1, 23, 16. Okay. Hopefully that all kind of made sense to you. You know, we kind of got lucky in the end here that we didn't have to do, some of those operations that we might see. Sometimes this process might be 1 or 2 steps longer than this particular example, but now you only have 3 left to try on your own. And once you're in a good spot with these, the assignment that I collect in this unit will probably be just a few more practice just like this, guys. So hopefully I'll see and hear from you, some of you, by tomorrow. And have a good rest of your day. We'll catch you guys later.